In the previous video, we fit a logistic regression model with two numeric variables and one dummy variable. And now what we'd like to do is apply that model to a set of new applicants. So the model was being used to predict whether or not somebody would apply for a bank loan. So there's a file of applicants that you need to download. And it's called loan applicants. So if we bring this in, notice that we've got the same columns out here, okay, starting with age and experience. There's no personal loan column. So in the previous video, we created a model with two numeric variables and one dummy variable. It was created from the bank loans data set. And the purpose of that model was to predict the variable called personal loan. So now what we want to do is use this data set called loan applicants, and this has been imported here into Python. It was from an Excel file called loan applicants, and it's got 10 new applicants for these loans, and we're going to try to predict whether they would take out the personal loan. So the numeric feature variables were age and income, and so that was column 0 and 2. So we're going to create a new X range with columns 0 and 2. We can see what this looks like. Now we know that we need to scale variables when they're numeric and we have more than one of them. So we'll copy up here our statement for scaling variables from up above, but we'll apply it to the new X1 range. So we'll transform X1 and create a new X1 with the transformed variables. And we can see what that looks like. Sometimes Python rounds things, but we can see these are spread out negative and positive around 1, typically based on where they're at relative to the mean. Now what we need to do is add the dummy variable. So we can just simply make our life easier by copying some of the statements that we used. So we'll add a new column, except this data with the new applicants we called applicants. We still want column 11 because column 11 was the dummy variable we used, which was credit card. And now we're dealing with X1. So now we're going to add the dummy variable to X1. Okay, so again, these are rounded, and sometimes logistic regression does that, but the actual number is still there. And then these are the dummy variables. So now what we can do is predict the applicants that are in X1. And it turns out they're all predicted not to take out the personal loan. We saw with the confusion matrix that there are many more people who did not take out the personal loan. This is not necessarily a surprise. Now what we could do, though, is look at the probability that they take out a personal loan. And again, Python is rounding here, but what we'll do is go in and output these probabilities so that we can see them in an Excel spreadsheet. So let's put those back as the prediction. and the probability of taking out a loan. And we want the first column, all of these are the probabilities that they actually take out the loan. And there will be to more decimal places when we output this to Excel. So we want all the rows, colon, and then the one column. And now we can see the probabilities out here. So while none of them were over 50%, we do see that some of them are significantly higher than others, so we may want to focus attention on the ones that still have the higher probability, because this is a low probability event to start with, signing up for this loan. Now what we can do is sort these, which is kind of a nice thing to do. And so now this person we see here is the highest probability of taking out a loan, so we could now focus our efforts on these people. And we can output this to Excel if we want to see this in Excel, or send it to somebody. Might certainly be a good thing to provide somebody in our customer service. And we can output that to Excel. So now we've completed running one model with multiple numeric variables and also a dummy variable, and making predictions and outputting the results.